Okay, so thank you for the introduction. And as mentioned, I work for IBM Research, and in IBM Research we have this a nice tradition of grand challenges. You may recall Deep Blue versus Garry Kasparov and Watson in the Jeopardy event. And shortly after this event, there was a call for proposals across our entire research division, where each of our thousands of researchers across the globe was entitled to come up with a proposal for the next grand challenge, the next big thing. And obviously many ideas came up, and soon enough the relevant management found themselves in what we can call a debatable situation. So there were many proposals to select from. Each proposal has its own pros and cons. It was not very clear which one to select, but nonetheless there was no escape from taking a decision. And interestingly enough, one of the two projects eventually selected, which is the one I will describe now, came from the IBM Haifa Research Lab, where we were proposing to develop technologies that will allow us as humans to better deal precisely with these debatable situations. So debating is a very common and very important human activity, and we experience that a lot in our daily life, in our professional lives. And therefore, it is perhaps interesting to observe that as of today, actually, we do not have a lot of technologies developed explicitly to enhance this important human activity. And this is the gap that we try to bridge in this ambitious research effort. And we started with about one slide a few years ago, and the project evolved rapidly. So we have today dozens of researchers fully dedicated to this research project in several different IBM labs across the globe. And of course, we do many things in this project, but in the next couple of minutes, I will describe a particular problem that drew much of our attention over the last few years. And it starts with the simple observation that most of the questions that we encounter through life do not have a simple factual answer. So shall IBM make a strategic partnership with Apple? Shall I buy a house, rent an apartment, maybe stay at home with my parents? Whether us as a society should ban the sale of violent video games to minors, and so on. And it seems that for this kind of questions, existing technologies are not enough. So question answering, at least in its classical form, was not designed to answer this type of questions, and search engines at best will bring us a bunch of relevant documents, but then we need to read and process these documents, which is time consuming. And therefore, we were led to think of something else. Can we pose these kind of questions to the computer and provide it with a massive corpus like Wikipedia, and then ask the computer to automatically generate pro and con arguments for the topic that we are discussing? And of course, in order to make progress in that, we need to define more clearly what we mean by an argument. And this is a question that typically is dealt with by philosophers and linguists, but we needed some kind of a working model. So we quickly converged to a very simple and robust model composed of only 3 parts. The first part is really the topic that defines the context of the argument that we would like to automatically construct. And then we have a claim, which is a general, high-level, concise statement that directly support or contest the topic. And finally, naturally, we have evidence, which are pieces of text that can be used to support or to contest the claim in the context of the topic that we are discussing. And when you think about it, you soon realize that evidence may come in different forms. We can use empirical studies, we can use expert evidence, maybe anecdotal evidence with some emotional impact, and correspondingly, we need to develop the tools to capture each of these evidence types independently. And I think the interesting situation is that we started with this vague, somewhat amorphic problem of automatically constructing arguments, and then we break it down into more modular and more tangible problems, and we realize that we are actually defining and pursuing problems that are not only scientifically interesting, but they also have practical value by themselves. And also these problems often received relatively little attention by the relevant communities. So think of the following problem. I give you a claim, and I would like a system that will find evidence to support or contest this claim automatically. This is a very natural problem with a lot of practical value, but as far as we know, we were actually the first to pose it in this way and to suggest a working solution that we presented last year at EMNLP. Now, these problems are very, very challenging, and to understand why, let us consider for a minute the problem of claim detection and in a corpus like Wikipedia. And typically we need to, at a very high level, we need to address two challenges. The first one is that in order to identify claims in a corpus, the computer needs to be able to make very subtle linguistic distinctions. So let's say that we are discussing whether or not to become vegetarian, and think of the following two statements. Being a vegetarian reduces the risk of cancer, or being a vegetarian means you do not eat meat. For us, it's very easy to understand that the first one can be used as a claim in a discussion about this topic, but the second one is more of a definition in this context. But to teach the computer to make these distinctions is quite challenging. The second issue that we need to address is that relevant claims are very rare. So in Wikipedia alone, we are talking about billions and billions of candidates, out of which typically only a few represent good and relevant claims. So often we use this kind of metaphor of finding a straw in a haystack, not a needle in a haystack, because not only what we are looking for is exceptionally rare, it is also highly reminiscent to its surroundings. So what do? Of course, we go back to the basics of supervised machine learning. We annotate data, we collect this annotated data. This is a tremendous effort by itself, but once we have these data, we train different machine learning algorithms on top of different natural language processing utilities in order to make progress, and you will see a demo in a minute, but before this demo, just one more slide. So I started with this slide of grand challenges of competitions between man versus machine, but I think we are heading through something else of more of a collaboration of man and machine. So think of the following problem. If I will give you a topic and I will ask you to generate claims, to suggest claims for this topic, for humans this is not an easy task. You can suggest 2 pro claims, 3 con claims. Most humans will get stuck at this point. For the technology I just described, to suggest 40 pro claims and 30 con claims, this is relatively easy. Now, it might be the case that 50% of these predictions will be wrong, but again, for the human to filter the wrong predictions from such a short, concise list, this is very easy. So I think this captures the notion of our vision of truly a synergistic collaboration of man and machine on top of these technologies. And in the demo, you will see precisely that. So basically, we are providing the computer with, as input only with this short sentence that defines this controversial topic, and Wikipedia with the billions and billions of candidates, and then out of the short list of predictions, I filter out a few of them, about 50% or even less, and what is left is what you're going to hear.
Hello, and welcome to the IBM Debating Technologies demonstration. To proceed, please select the topic and I will share with you my top claim and evidence predictions.
So there are several topics here. All of them are new to the computer. It was not included in the training data. And let's pick this one.
You have selected the topic, vegetarianism should be promoted. I would like to raise the following claims in support of the topic. A vegetarian diet is rich in vitamins. In addition, vegetarian diets are low in saturated fat. Furthermore, a vegetarian diet can help prevent heart disease. Moreover, vegetarianism will help improve public health and curb starvation. Additionally, killing animals should be rejected unless necessary for survival. Finally, many examples of animal behavior and intelligence seem to indicate emotion.
So I hope you noticed there are some non-trivial observation made by this system, and then let's hear the con claims.
You have selected the topic, vegetarianism should be promoted. I would like to raise the following claims that contest the topic. Adopting a vegetarian diet may be a way of focusing on personal actions and righteous gestures, rather than systemic change. In addition, strict vegetarian mothers as well as their newborns have a greater incidence and risk of anemia and iron deficiency. Finally, strict adherence to veganism can become an obsession.
So as you heard, it can become an obsession. And just one more topic that sometimes we find amusing. Remember that all of this is done on top of Wikipedia.
You have selected the topic. Wikipedia is reliable. I would like to raise the following claims that contest the topic. Wikipedia explicitly is not designed to provide correct information about a subject. In addition, Wikipedia has a long-standing controversy concerning gender bias and sexism. Furthermore, Wikipedia is a flawed and irresponsible research tool. Additionally, Wikipedia may have a benign, even trivial face, but underneath may lie a more sinister and subtle threat to freedom of thought. Moreover, many articles have inaccuracies or are outdated. Finally, Wikipedia is perceived to promote consensus and not truth.
So correspondingly, we are starting to explore other corpora beyond Wikipedia, and by that I will close. Thank you for your attention.